Hello, my name is Alexandra Arranja. I'm Portuguese and I'm an early stage researcher under the Marie Curie Actions. I'm doing my PhD in Strasbourg at the Institute Sartre under the framework of an European project called TRACE nTREAT. The main goals of this project are to find strategies to trace and treat cancer through the use of nanotechnology. Within this project, my work is focused on the development of assembled nanocarriers to deliver radioactive elements for imaging and radiotherapy of cancer. These nanocarriers are very small structures, about the size of a millionth of a millimeter, and they can naturally accumulate in the tumor much more than they do in normal tissues. This happens because the vasculature around the tumor site is effective due to the uncontrollable growth of cells. The tumor vessels are abnormal with wide fenestrations, which leads to the passive diffusion of these nanocarriers. On the contrary, in the healthy tissues, cells grow and divide in a controlled manner, with a healthy endothelium, so these devices will not diffuse through the capillaries. To develop these nanocarriers, I use tri-block copolymers, which are polymers composed by repeating units of different monomers. Each repeating sequence of the same monomer is called a block, and the tri-block copolymers are composed by two hydrophilic blocks and one central hydrophobic block. In appropriate conditions of concentration and temperature, these polymer chains aggregate together to assemble into the nano-sized structures, which are called micelles. The formation and disaggregation of these structures is very dynamic, and they can easily disaggregate, for example, when they are extremely diluted in the bloodstream. Therefore, my work is focused on the design and stabilization of these structures. To stabilize the micelles, I use a hydrophobic molecule that is retained inside the micelles, and upon a cross-linking reaction of several molecules, a polymer network is created, which tightens the central part of the micelle and stabilizes them. By using chemically modified polymer chains, I can obtain nanocarriers containing the radioactive elements to trace and treat tumors. My PhD is also focused on the toxicological evaluation of these nanocarriers using cell culture. Studying the toxicity of the materials in human and rat cells is critical for their safe use in medicine. Also, understanding their intracellular effects might open new insights on treating cancer. By exploiting these natural processes of accumulation of these nano-sized structures in the tumor site, nanotechnology can lead to the improvement of conventional treatments by delivering the therapeutic agents specifically to the tumor site, thus increasing the effectiveness of therapies and reducing the side effects. We believe that the TRACE nTREAT project will improve the current diagnosis and treatment of cancer and might lead to important discoveries in the near future.